Hello guys, so in this example we're going to go over how to find one of the most important concepts of this class. It is called the partial derivative. So what does that mean? So basically partial derivatives are basically when we take derivatives of multivariable functions, but we're only taking them with respect to one variable at a time. So for example, we have a function of x, y, z. So what we do is, let's say we want to take the partial x, which is denoted as f and then a subscript of x. And then basically what we do is when we take the partial derivative with respect to x, we treat the y and z component. So I'm going to treat x as my function, and I'm going to treat y and z, which I'll have in a different color, as a constant. So we're going to treat this as a constant of 1. So now when we take the partial derivative with respect to x, we take the derivative of x. So the derivative of x is just 1. And then since it's being multiplied by a constant, we include this in our answer. So the partial derivative of x is just simply equal to yz. Now, the same thing is true for f of yz. So when we're taking the partial derivative with respect to y, we treat our everything that's a y as a function, and everything that's x as everything that's not y as a constant. So in this case, our x and z are our constants of 1. So basically cover them up and just differentiate with respect to y. So the derivative of y with respect to y is 1 times our constant, which is x of z. So it's simply just equal to x of z. And then we do the exact same process for f of z. So we treat our z as our function that we want to derive, and then everything else, our xy, we treat it as a constant of 1. So whenever you're taking a derivative, you basically pretend that this right here, you're only taking the derivative with respect to z. So with respect to z, the derivative of z is 1. The derivative of, and then this is a constant, so this would simply be xy. So this is equal to xy. So basically, just if you're deriving with respect to z, only look at the z and take the derivative. If you're deriving with respect to y, only look at the y. If you're deriving with respect to x, only look at the x. So now we're going to do our second example. So right here, we are given a function of z times cosine xy. So it's a little bit trickier, but it's still the exact same thing. So first thing we're going to do is we're going to find the partial with respect to x. So when we're taking the partial with respect to x, since they're being multiplied, we treat our z as 1. So we're really only focused on the cosine of xy. So for constants, I'm going to just have them in red. And cosine of xy. So the derivative of this is we ignore the z and we simply focus on the constant of xy. But since it's with respect to x, what if we substitute the y for another constant? Like let's say 5, right? So cosine of 5x. Now this makes it a lot easier. The derivative of cosine of 5x is negative 5 sine of 5x. So what would the derivative of cosine of xy be equal to? It'd be equal to negative y, because y is our constant, times sine of x times y, or y times x. And then this is all being multiplied by a constant, so we include this in our answer as well. So to present this answer more properly, the partial derivative with respect to x is equal to negative y times z times sine of yx. So that's how we take it with respect to x, but what if we need to take it with respect to y? So with respect to y, we would do something slightly different. So with respect to y, we're doing the exact same thing, except we're doing it with respect to y. So we're still doing this function down here. So I'll write it up here. Z times cosine xy. So z is a constant, so we're going to go ahead and eliminate it for now. Z dotted with the function that we're focusing on is cosine of xy. So we're going to pretend that our x is our constant. So what is the derivative of cosine of 5y? The derivative of cosine of 5y would be negative 5 sine of 5y. So similarly, we treat x as a constant. So the derivative of cosine of xy is going to be equal to negative x times sine of the constant x times the variable y, because we're taking the derivative with respect to y. Now don't forget we had a z over here, so the proper answer would be negative x times z times sine of x times y. And this is the derivative with respect to y. Now how about with respect to z? Now z is outside of the cosine. It's not within the cosine. It's actually outside of the cosine. So it actually makes it even easier, believe it or not, because what's our constant, I'll have color coded in red, is going to be cosine of xy. And the derivative that we're actually taking is only z. So we treat the cosine of xy as a constant. So similarly, so we're going to pretend all this cosine of xy, we're going to say it's equal to 3. And then this is our z. So what is the derivative of 3z? The derivative of 3z is just 3. Right? So now similarly, what is the derivative of cosine of xy times the variable z? Is this is a constant. And z, so what's the derivative of z? The derivative of z is 1, right? So it's 1 times our constant of cosine of xy. So essentially, the derivative of z is just cosine of xy. So what did we do? We treated this as a constant. So it helps me substituting in constants to see what those derivatives come out to be. So then I can focus on just taking the derivative of z, or with respect to z. So this is our final answer. So if your answers don't match up these, then go ahead and just follow this video step by step. But partial derivatives are one of the key concepts. So really just whatever you're taking the derivative of, make sure that that is whatever is not that variable is treated as a constant. Color code it or do something to remind yourself that it's a constant. So anyways, hello guys. So in this video, we're going to learn how to take, we're going to do partial derivative examples. A little bit more complex than the last video, but nonetheless still very easy. So we're going to take the partial with respect to x, partial with respect to y, partial with respect to z. But since this is a longer function, I'm going to just go ahead and do this on another sheet of paper. So our function of, our multivariable function of f of x, y, z is equal to e to the x times cosine of 4z times y. So now we're going to go ahead and take the partial derivative of this function with respect to x. So the partial derivative with respect to x. So whatever is a constant, I'm going to color code it in red. Since we're only taking the partial derivative with respect to x, our constants are y times cosine of 4z. This is all a constant. So we do not take this derivative. But we do have a function of x, which is e to the x. And we do take the derivative of this function. So furthermore, this is simply a constant. So when taking the partial derivative, what's the derivative of a constant being multiplied by something? So we're going to pretend this is a constant of 3. We're just making this easier for ourselves. So 3 times e to the x. What's the derivative of 3 times e to the x? It's simply 3. And the derivative of e to the x is e to the x. So the constant times e to the x. So similarly, what's the derivative of this being multiplied by this? The derivative of e to the x is simply e to the x. But the derivative of the constant, it's not an addition, it's multiplication. The constant is included in the answer. So it's y times cosine of 4z times our x function. The derivative of e to the x is e to the x. So this is what is equal to our f of x. Now, f of y, similar, but not quite. So for f of y, whatever is not our y term, we're going to go ahead and cover it up and just color code it a different color. So draw a line, separate. We're starting the derivative, partial derivative with respect to y. So e to the x times cosine of 4z times the variable that we're actually trying to find the derivative of, which is just y. So similarly, all this right here is simply a constant. So to take the derivative of this, we're just going to take the derivative of y. So what's the derivative of y with respect to y is equal to 1 times the derivative of times the constant in front of it. We're just going to treat this as a constant. So it's e to the x times cosine of 4z, which is just equal to e to the x times cosine of 4z. Now, we're going to go and compute f of z. So the next step is to compute f of z. So f of z of this function right here that we have, same function. So what we're going to do is we're going to treat whatever is not our z term is as a constant. So e to the x times y dotted with cosine of 4z. So this is a constant. So this is simply a constant being multiplied by this. So we're only focusing on this. So what's the derivative of cosine of 4z with respect to z? So the derivative of this, you apply the chain rule, which I'm just going to do because I have another video where I go over how to do the chain rule from calculus 1. So the derivative of this function would be equal to negative 4 cosine, or sine, sorry. Got me. Negative 4 sine of 4z. But we're multiplying it by a constant. So the partial with respect to z is the constant, which is this term, times the derivative of with respect to z, which we got to be this term. So this is our final answer. Furthermore, you could simplify this by just putting the 4 in front, but I'm going to choose to leave it like this for simplicity's sake. But that's how you take the partial derivatives with respect to x, y, and z. Now here, we're given example 2, which is it looks quite complicated, but it's really not that complicated. So the partial derivative with respect to z, it's asking for the, let's see if I can capture it. Let's see. So the partial derivative, which I'll do on another sheet of paper. So I'll just copy it down here. So we're given this function, the natural log of y times x squared times the square root of z. So with respect to x, we treat the natural log of y times the square root of z as a constant. And we solely focus in on the x term, which is x squared. So to compute the partial derivative, we're only going to focus on the x squared. So what's the partial derivative? So what's x squared? What's its derivative? Simply just 2x times this constant that we color-coded in red. And that's our partial with respect to x. Now, how about with respect to y? With respect to y, okay, it's a little bit trickier, so I'll do it on another sheet of paper. So, first thing we do is I'm going to go ahead and copy the problem down. So, f of x, y, z is equal to the natural log of y times x squared times z. So now all we simply do is just we're taking it with respect to y. So what's the first thing we do? We treat everything that's not a y as a constant. So in this case, x squared times the square root of z is a constant. And the derivative that we actually focus on is the natural log of y. So we're going to take the derivative of this, of the natural log of y. And what's the derivative of the natural log? If you don't know how to take the derivative of the natural log, I do have a video on that in my Cal 1 playlist. But simply, the natural log of x is equal to x prime over x. So similarly, the natural log of y is just simply equal to y prime over y. And what's the derivative of y? Is 1 over y in this particular case. Keep this over here. So f of y is equal to our constant times the derivative of the natural log of y, which is simply 1 over y. So that's the derivative of f of y. Now with respect to z, the derivative with respect to f of z. So the first thing we do, which I'll put a line right here to separate. The first thing we do when we're taking the derivative with respect to z is we treat the x and y components as a constant. And I know I feel like a broken record that I keep repeating this, but trust me, it helps you when you have bigger problems to remind yourself that whatever you're not taking the derivative with respect to that's being multiplied, treat that as a constant. So we're solely taking the derivative of z to the z inside a square root, which I will call z to the 1/2 to make it easier for me to take the derivative. So the derivative, so now we're going to take f of z is equal to the derivative of this, z to the 1/2. The derivative of a square root would be 1 over 2 times z times, put a little equal sign right there, the constant x squared times the natural log of y. And this is how you take the partial derivative. So basically what you're not taking the derivative with respect to, treat it as a constant. always treat it as a constant. Now, I'll do one more quick example just because I feel like I didn't cover it in this video, so I'll cover it really fast to not bore you. But I think you do need to understand it. So, what if we're given a function of f of x, y, z is equal to x squared plus y squared plus z squared? So I didn't notice in all the examples I didn't have any addition. I only had multiplication going on. So basically what you do is, let's say we're taking the derivative with respect to x. Now, we're going to color code our constants in red. So, and whatever we are taking the derivative, we're going to color code it in brown. So x squared plus y squared plus z squared. Now, you're going to treat these as constants. So what's the derivative of a constant? The derivative of y squared, what if it's a constant of 1 or 2? The derivative is 0. So the derivative of z squared is 0. If we're doing it with respect to x, it's 0. Now we're doing it with respect to z, it's 2z. But in this case, we're asked to do it with respect to x. So it is 2x. So this is how we do it for the partial with respect to x is equal to all this, which is just simply equal to 2x. So whenever you have, like let's say you're taking it with respect to partial x, when you have a function, a term that does not have an x variable, you treat the whole thing as a constant as you would, for example, 3x plus 5. What's the derivative of 3x plus 5 with respect to x? It's just 3, because the 5 goes to 0 and the 3x goes to 3. Now similarly, f of y and f of z, you do the exact same process, which I will do real quick for you. So in this case, our y squared is the derivative that we are taking. The constants that I'll color code in red are z squared and x squared. So the derivative of this is simply equal to the derivative of y squared, 2y plus 0, so it's simply 2y. And the derivative with respect to z is you do the exact same process. So x squared is a constant, y squared is a constant. However, z squared is what we are taking the derivative with respect to. So our z squared, we take the derivative of z squared with respect to z. The derivative of y squared with respect to y is 0. This goes to 0. The derivative of the constant is 0. The derivative of z squared is 2z. And that's how you take partial derivative. And you use this a lot in multivariable calculus for directional derivatives, Lagrange multipliers, etc. A lot. Saddle points, relative max-min. But thank you for watching. I hope that was helpful. Thank you for watching. I hope that was helpful.